Now, before starting with the example, let us revise some of the concepts which we have already studied. If we know vector normal perpendicular to the plane and perpendicular distance of plane from origin, then we can write equation of plane in vector form. Suppose n cap is a unit vector normal to the plane p, it is perpendicular distance of the plane from origin, then equation of plane in vector form r bar dot n cap equal to p. If we know direction cosines of normal to the plane, suppose L, M, N, they are direction cosines of normal to the plane, and P, perpendicular distance of plane from origin, then equation of plane in Cartesian form Lx plus My plus Nz equal to P. So here coefficients of x, y, z, they are direction cosines of normal to the plane. Now line or vector has direction ratios or direction cosines. Plane does not have direction ratios or direction cosines. Equation of plane can be written in Cartesian form like this also: ax plus by plus cz plus d equal to 0. Here coefficients of x, y, z, they are direction ratios of normal to the plane. If we know position vector of any one point in the plane and vector normal to the plane, suppose A is point on the plane whose position vector is A bar and vector normal to plane N bar, then equation of plane in vector form r bar dot n bar equal to a bar dot n bar. Here dot product of vector quantities is there. So we can say this is vector form of equation of plane in dot product or scalar product form. If we know coordinates of point in the plane and direction ratios of normal to the plane, then also we can write equation of plane, but it is in Cartesian form. Suppose coordinates of point, one point in the plane x1, y1, z1, and direction ratios of normal to the plane ABC, then equation of plane in Cartesian form x minus x1 into A plus y minus y1 into B plus z minus z1 into C equal to 0. If we know coordinates of one point on the plane, but instead of direction ratios, if we know direction cosines of normal to the plane, then equation of plane in Cartesian form in bracket x minus x1 outside bracket L plus in bracket y minus y1 outside bracket M plus z minus z1 outside bracket n equal to 0. if we know position vector of one point in the plane and vectors parallel to the plane. Suppose position vector of point A in the plane is A bar, B bar and C bar. These are the vectors which are parallel to the plane. Then equation of plane in vector form, R bar dot B bar cross C bar equal to, on right hand side we get A bar dot B bar cross C bar. Here dot and cross product is there. Three vectors are also there. So this scalar triple product can be expressed as box product. Now same equation of plane can be written in another form, in vector form only. But here B bar and C bar, they are parallel to the plane. A bar, position vector of point in the plane. Then equation of plane can be written R bar equal to A bar plus lambda B bar plus mu C bar. Here lambda and mu, they are real numbers, scalar quantities. Here they are also known as parameters. So this is vector equation of plane in parametric form. This is also vector equation of plane, but it is in non-parametric form because here parameters are absent. We can find equation of plane passing through intersection of two planes. Suppose equations of two planes are R bar dot N1 bar equal to D1, R bar dot N2 bar equal to D2. Then equation of plane passing through intersection of these two planes, R bar dot in bracket N1 bar plus lambda N2 bar equal to D1 plus lambda D2. For every real value of lambda, we get one plane, and lambda can have infinite number of real values. So we get infinite planes passing through intersection of two planes. If equations of two planes, they are in Cartesian form. For this plane A1, B1, C1, they are direction ratios of normal to the plane. A2, B2, C2, they are direction ratios of normal to this plane. Then plane passing through intersection of these two planes in one bracket, A1x plus B1y plus C1z plus D1 plus lambda into bracket A2x plus B2y plus C2z plus D2 equal to 0. For this plane N1 bar, it is a normal vector perpendicular to the plane. Here N2 bar, it is a normal vector perpendicular to the plane. Now let us see this example. Find the vector equation of plane passing through intersection of planes. R bar dot in bracket 2i plus 2j minus 3k equal to 8. R bar dot in bracket 2i plus 4j plus 3k equal to 7, and through the point 2, 1, 3. Now these are the two equations of planes in vector form. When two planes are intersecting, their intersection is a line, and we have to find equation of plane passing through that line, which is intersection of two planes. Through a line, infinite planes can pass. So we get infinite number of planes passing through intersection of two planes. But one more condition is given, that required plane passes through given point. So these planes, they are of the form r bar dot n1 bar equal to d1, r bar dot n2 bar equal to d2. n1 bar, vector normal to the first plane, 2i plus 2j minus 3k. n2 bar, 2i plus 4j plus 3k. Equation of plane passing through intersection of these two planes. R bar dot in bracket n1 bar plus lambda n2 bar equal to d1 plus lambda d2. Put the corresponding values. Here d1 equal to 8, d2 equal to 7. R bar dot n1 bar and n2 bar we shall write in brackets. So outside we shall use another bracket, square bracket. In that round bracket, 2i plus 2j minus 3k plus lambda into bracket, 2i plus 4j plus 3k equal to 8 plus 7 lambda. In bracket, there are two terms containing I, two terms containing j, two terms containing k. So we shall collect terms of I, j, k. R bar dot 2i plus 2 lambda. If we take I common, we get in bracket 2 plus 2 lambda plus collect terms containing j, 2j plus 4 lambda j. Take j common, in bracket 2 plus 4 lambda into j plus collect terms containing k. Take k common, so we get minus 3 plus 3 lambda into k equal to 8 plus 7. So we have collected terms of I, j, k separately. To get equation of required plane, one more condition is given, that plane is passing through this point, and by using this condition we can find value of lambda. Now these are the coordinates of point, so we can put them as values of x, y, z. So we want equation in terms of x, y, z, means this equation we have to convert into Cartesian form. For that purpose, suppose capital R, it is a point in space whose coordinates x, y, z. Then its position vector xi plus yj plus z. We have to use values of x, y, z so that we get value of unknown lambda. For that purpose, we have to convert equation of plane from vector form into Cartesian form. For that purpose, we have written r bar in terms of x, y, z. Vector in other bracket as it is. Dot product of two vectors. Dot product of two vectors is a scalar quantity. And as both the vectors, they are expressed in terms of ijk. To get their dot product, we have to find sum of product of coefficients of ijk. Here, coefficient of I x. Here, coefficient of I 2 plus 2 lambda. X into bracket 2 plus 2 lambda. Plus y into 2 plus 4 lambda. Plus minus 3, your coefficient of k is z in bracket minus 3 plus 3 lambda equal to 8 plus 7 lambda. ijk unit vectors have eliminated. Equation contains x, y, z. We have to find value of lambda. Observe right hand side. 8 plus 7 lambda. 8, it does not contain lambda. Next term contains lambda. So on left hand side also, we shall collect those terms first which do not contain lambda. We have 2x plus 2y minus 3z. After that, collect terms containing lambda. 2 lambda x plus 4 lambda y plus 3 lambda z. Take lambda common. In bracket we get 2x plus 4y plus 3z. Right hand side as it is. Compare terms which do not contain lambda. So we get 2x plus 2y minus 3z equal to 8. But here we have to find value of lambda, and for that one condition is given. It is more convenient to use that condition. Put values of x, y, z. So here x equal to 2, y equal to 1, z equal to 3. 2 2s are 4, 2, 3 3s are 9, plus lambda into bracket. 2 2s are 4, 4 1s are 4, 3 3s are 9, equal to 8 plus 7 lambda. 6 minus 9 minus 3. 8 plus 9 plus 17 lambda equal to 8 plus 7 lambda. Collect terms containing lambda on LHS. 17 lambda minus 7 lambda, 10 lambda. Collect remaining terms to the RHS. 8 plus 3, 11. So lambda 11 by 10. So we have got value of lambda here. After that, we have to put value of lambda in this equation. If we put value of lambda in this equation, we get plane which is passing through intersection of two planes and which passes through given point. So put value of lambda 11 by 10 in equation 1. After simplification, we get required equation of plane. So here equations of two planes, they are given in vector form, and we have to find equation of plane passing through their intersection in vector form also. Although we have to form equation of plane in vector form, here we have converted equation of plane into Cartesian form because we have to use this condition. This is a point which lies on the plane, so we have to put values of x, y, z. For that purpose, we have converted equation of plane into Cartesian form. After getting value of lambda, we write equation of plane in vector form only.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is a IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10 NTSC MTSC, 6th and 9th Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkhera, Aurangabad, or call 95112 70135 or 95112 66680.